Hi guys, welcome to your favorite channel, Mathematics Appreciation. Today we'll be talking on variance and standard deviation. If you are given a simple data set, how do we obtain the variance and standard deviation? Now let's go to the board. So we have a data set on the board here consisting of 24 data points. That's the size of the data is n equals 24. Okay, so the first thing for us to do is to partition the data set into intervals, and the first column here is for the class interval. Before we can do that, we need to consider the range. The range guides us on how to partition the data set into interval. So the range for the data set is there. The highest value here is 40 and the least value is 3. So range is simply the highest value minus the least value, which is 40 minus 3, and that's 27. Now the size of each of the classes, otherwise called the class width, is simply the range divided by the number of classes we wish to partition our data set into. And the number of classes we wish to partition our data set into is a discretion of the person solving the problem. For me, I choose to partition this data set into 4 classes because I've seen that the highest value is 40. So I can easily say, okay, let's take 10 per class, okay? So another person may choose to partition the data set into 3 or more classes. So that's 37/4, which is the range divided by the number of classes I wish to partition the data set into, and that's 9.2. Here we round it up to the next higher number, and that is 10. Okay, so now that we have 10, it means that each of the classes will contain 10 elements, 10 data points, each of these entries. So I now have 1 to 10, that's 10 of them, 11 to 20, which will still contain 10, 21 to 30, that's 10, and 31 to 40. So we move ahead because we know that we will need the mean of this distribution to be able to get the variance. So we now get the midpoint, otherwise known as the class mark. Class mark is simply the arithmetic mean of these 2 class intervals. That is 1 plus 10 divided by 2. That gives us 5.5. And this is 11 plus 20 divided by 2 will give us 10.5. We take a similar approach, we get 15.5 here and 25.5 here. So we need to get the frequency for each of the class interval. That is the number of data points here, or entries here, that fall within this class interval. That's between the space boundary of 1 and 10. So we now go back to the data set and count. Okay, so numbers between 1 and 10 here is 1 here, 2 here, 3, 4, 5, 6, 7, 8, 9, and 10. So that's why we have this 10 here. That means the numbers that fall between 1 and 10, we have 10 of them. So we go back to the data set again and count the number that fall between 11 and 20. We have 1 here, 2 here, 3 here, just 3 of them. So that's why we have these 3 here. We go back to the data and count the number of data points or entries that fall between 21 and 30. We have 1, 2, 3, 4, 5, 6. That's why we have this 6 here. Then for the class interval 31 to 40, we go back to the data set and count the number of entries that fall within that particular interval. 31 to 40, we have 41 here. 40 is here as number 1, number 2, number 3, number 4, and number 5. So that's why we have 5 here under frequency. So the next thing for us to do is to multiply the column of the midpoint with the frequency to have this column. 5.5 will give 10. Sorry, 5.5 times 10 will give 55. 10.5 times 3 will give 31.5. 15.5 times 6 will give 93. And 20.5 times 5 will give 102.5. We need that column because that is the column that will help us to get the mean, this particular value here, the x bar, since we will need that to be able to get the variance. Of course, at that point, we now pause and obtain the mean. And the formula for mean is x bar equals sum of f of x over sum of f. If you're not familiar with how we obtain the mean, you have a course on the channel that has to do with the mean. You can go there and have a refresher training on that. So if we divide 282, which is sum of f of x, by 24, which is sum of f, we have the mean, which is 11.8. The mean is 11.8. The mean of 11.8 now will help us to obtain this column, x minus x bar. We simply subtract 11.8, which is x bar, from each of these variables, x's. So that will be 5.5 minus 11.8, that will give us minus 6.3. 10.5 minus 11.8 will give us minus 1.3. 15.5 minus 11.8 will give us 3.7. 20.5 minus 11.8 will give you 8.7. Okay, so now that we have this column now, we need to square this column to be able to get to where we obtain the variance. So we square each of this. Minus 6.3 squared is 39.7. Minus 1.13 squared is 1.7. 3.7 squared is 13.7. 8.7 squared is 75.7. So if we sum this column now, we have 130.8. So that is here now, as in the summation of x minus x bar all squared. And we divide that by the summation of f, that's the frequency column, to have our variance, which is sigma squared. So we now have 130.8 over 24, and that gives us 5.45. That is the variance for this particular data set. So after getting the variance, the standard deviation is just a stone throw away, because we need to take the square root of the variance, the positive square root of the variance, to result in standard deviation. And that's what we have here, sigma, which is simply the square root of variance, sigma squared, which is the square root of what we have here, and that's the square root of 5.45, and that gives us 2.33. So for this given data set, the variance is 5.45, and the standard deviation, which is the square root, positive square root of variance, is 2.33. We are happy that you've been able to watch this particular video up to this point in time. I'm sure you've learned something from here. Please, we appreciate you if you like, comment, subscribe to our channel, and share this particular video. Thank you very much.